Geometry students, in this video, we'll be studying one of three ways that we are going to learn to prove that triangles are similar. In other words, we are going to learn a total of three ways to prove that two triangles are similar, okay? We will learn one of those ways today, and we'll learn two other ways in lesson 8.5. Your heading for today, students, is proving similar triangles by AA method. That's angle method, okay? And we'll talk more about that in a little bit, but please copy your heading down. Proving similar triangles by AA method, lesson 8.4, and be sure and include today's date, okay? Be sure and include today's date so that your notes are organized. Alright, let's continue on. Chapter 8, so far, listen carefully, has been about similar polygons. I mean, we've looked at all kinds of polygons. Triangles, quadrilaterals, heptagons, hexagons, octagons, whatever. Okay, pentagons. In this video, though, we are going to turn our attention to only one type of polygon, and that is the triangle. Okay, so for this video today, and to be honest with you, in some upcoming videos, we're going to be focusing on similar triangles. Okay, remember, if two triangles are similar, then the following two statements are true. And I think it would be really a bad idea for you guys not to copy this down. I would encourage you to copy this down. If two triangles are similar, then the following statements are true. Okay, so I would write this in your notes if I were you. So students, here's one triangle. You can draw that in your notes if you want to. Then I would draw one a little bigger, and we're just going to pretend, even though my drawing skills are definitely pretty poor, I'm going to pretend these two triangles are similar, okay? We're going to call this angle A, B, C. We're going to call these angles D, E, and F, okay? Now, please listen carefully. If two triangles, or for that matter, polygons are similar, then the following statements are true. First of all, the angles are congruent. So I'm going to go ahead and say the triangle A, B, C is similar to triangle D, E, F. Okay? Now, having made this similarity statement, I can now state that angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. Okay? So when two polygons or triangles are similar, their angles are congruent. Please don't forget that. Now, I can also then state, if these two triangles are similar, I can say AB over DE. Equals BC over EF. Equals AC over DF. Now, what that means is all these sides are what? What do we call it? Proportional, okay? So, when two triangles or polygons are similar, their angles are congruent and their sides are proportional. Please don't forget that, guys. It's very, very, very important. Alright, moving on. Now, if you were to draw a triangle with angles 20, 50, and 110 degrees, and then draw a non-congruent triangle with the same angle measurements, the two triangles would always be similar. Always, okay? So, let me demonstrate this real quick. For example, and you can take notes on this or just watch. I'm going to draw an angle here. It's about 20 degrees. And then up here, we'll make this about 50 degrees. And then this angle here is about 100 degrees, okay? So let me quickly do this, make it a little bigger so we can use it. Now, students, very quickly, let's go ahead and put 20 degrees here, 100 degrees here, 50 degrees here. I'm being a little sloppy. I'm trying to hurry to show you something. 20. And again, I would encourage you to take notes on this, although this part here, if you just want to watch, that's fine. Now, I'm not going to do a proof on this. In fact, actually, we don't prove postulates. They're kind of just understood because they're common sense, to be honest with you. Now, guys, it is common sense that if the angles are the same in two triangles, the two triangles are not necessarily congruent, but they are similar. Now, they might be congruent, but they don't have to be. But they're definitely similar, okay? So, what I want to show you is, whenever you have three angles in one triangle, congruent to three angles in another triangle, those two triangles will always be similar. Okay, now I hope that makes sense to you. Jumping off of that premise, we're now going to say this, okay? Watch carefully. With this in mind, this leads us to the one postulate that we're going to be looking at today, okay? So here it is. Please watch carefully. Or please copy this down. Postulate 20, the angle, or we also call it AA, similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Now, are they congruent? They might be. We don't know for sure, but they're definitely similar. Okay? Now, guys, I hope you're seeing this. It's common sense, guys. Let's go back to my original, or my last, two drawings I had up here. Now, please watch this carefully, guys. I'm going to erase the 100 degrees and erase the 100 degrees. Now, watch how this makes total sense. If I've got two angles in this triangle, congruent to two angles in this triangle, then I know for sure this third angle, I'll call it X, has to be the same as this angle over here. It has to be, because the three angles have to add up to 180. These three angles have to add up to 180. So if two angles in one triangle are congruent to two angles in another triangle, then we know for sure that all three angles are congruent. Thus, we have similar triangles, okay? So I would copy this down, okay? And actually, I'm not going to keep, I'll go and do this. Let's see. Copy this down, please, very quickly. Draw a triangle here, and we'll draw a triangle here. Alright, we're going to call this A, B, C. Please copy this down, students. D, E, F, okay? And I'm going to come over here and put if angle A is congruent to angle D, and angle B is congruent to angle E, then triangle A, B, C is similar to triangle D, E, F. Now, if I'm going too fast, let me know, okay? I'll try to slow down. I'll give you a second to copy that. Okay, but there it is. This is a picture of what the postulate says. If two angles in one triangle are congruent to two angles in another triangle, then for sure we know the two triangles are similar, because if two angles are congruent to two angles, then the third angle definitely has to be congruent also, okay? And don't forget, once you state that two triangles are similar, you can then state that their angles are congruent, okay? By definition of similar polygons, because the definition of similar polygons is you must have congruent angles. Alright, now let's continue on. Let's apply this information to some problems, okay? Here we go. Two triangles are both isosceles. I'd like you to copy this problem in your notes, please. I will pause a second while you copy this down. Two triangles are both isosceles. The vertex of both of these triangles is 52 degrees. Are these two triangles similar? Why or why not? Maybe they are, maybe they're not, okay? So go ahead and copy this down. I'll give you a couple seconds to do that. Then let's take a look at this problem. If you would like to work ahead in this problem, feel free to do that, but make sure you get it right, okay? isosceles triangle. I'm going to go ahead and mark this side congruent to this side. Then I'm going to draw one that's not congruent because it says they're not congruent. Actually, it does not say that. We're going to get to one later that does say that in a second. But for now, we have two triangles. They're both isosceles. And their vertex angle is 52 degrees. So I'm going to put 52 degrees here. And 52 degrees here. Now, are these two triangles similar? Well, guys, let's think about this for a second. We learned a theorem a long time ago that if two sides of a triangle are congruent, then their opposite angles are congruent, okay? So because these two sides here are congruent, I know this angle here is congruent to this angle here. So if I take 180, and my pen has been messing up a lot, guys. It's totally messing up now. Hold on a second. I'll try it over here. If I take 180 and subtract 52 degrees, then I'm going to be left with 128 degrees. Okay? Now, that means these two angles here have to add up to 128. Well, if I know the two angles are congruent, then just divide this by 2, and I get 64 degrees. Well, students, think about it. The same thing's going to happen over here if this angle's 52, which it is, and this angle's 52, which it is, and these two sides here are congruent to each other. That means these two angles here have to be congruent. They're both going to be 64 degrees also. So the answer is yes. These two triangles are similar because if I have two angles of one triangle congruent to two angles of another triangle, then the two triangles are similar. Or in this case, you could say if I have a polygon in which all the angles are congruent to their corresponding angles over here, then the two polygons are similar. So yes, they are similar. Why? Because once again, the angles here are congruent to the angles over here. Alright, let's continue on to another problem. Now, please copy this down. Now, students, listen to me. If you want to work ahead, that's fine. But please copy this in your notes and then work ahead. Are these two triangles similar? Let's draw a triangle like this that has 45 and 35 degrees for its angles. Then draw a triangle like this that has 45 and 100 degrees. Now, we really don't know for sure yet if these two triangles are congruent. I mean, similar, because I do not have two angles here congruent to two angles over here. I have one angle. This angle here is congruent to this angle here. So what I'm going to do is I'm going to find this missing angle over here. So 100 plus 45 is 145. If you subtract that from 180, you get 35 degrees. So now that I found this missing angle, look what I have, guys. I have 45 degrees congruent to 45 degrees. I have 35 degrees congruent to 35 degrees. Now remember, this angle postulate only works when you're dealing with what? Triangles, okay? But are these two triangles similar? Yes, they are. Definitely, because I have two angles in one triangle congruent to two angles in another triangle. Okay? So there we go. Alright, moving on to another problem. Now, we have not done proofs for a while, so let's try one, okay? Contain your excitement. The only thing different is we are definitely going to do this one as a paragraph proof. So you'll definitely want to listen and take notes. I would encourage you to not work ahead, okay? This is going to be a paragraph proof. So go ahead and copy this in your notes. I'll pause a second while you do that, and then we'll continue on. Okay, students, I'm going to start here in a second, kind of brainstorming. If you're still copying this down, don't stress out. Just go ahead and keep copying this down and listen while you're finishing it up. Okay, now if you look at what you're proving, students, you're proving these two triangles are what? Similar. Now we've only learned a couple ways to do that. We know if the angles are congruent and the sides are proportional. We know the triangles are congruent by the definition of similar polygons. But there's another way we just learned, which is angle, angle. Okay? And so let's just talk about this for a second. Let's brainstorm. Let's get some numbers up here. Angle 1, 2, and 3. Angle 4, 5, and 6. Now, right away we should recognize that angle 3 is congruent to angle 4. Now understand something, students. We are not doing the proof. We're just brainstorming, okay? Now, I know these two angles are congruent because they're vertical angles when two lines intersect. Their vertical angles are always congruent. We know that. Now, look, students, this is just like the problem we did over here. When you have two isosceles triangles and the vertex angle is congruent, then you know these angles here are congruent also. Look, same thing. I've got 2 marks here, 2 marks here. So this triangle's an isosceles triangle. I have 1 mark here and 1 mark here. So this triangle's an isosceles triangle. Look at the vertex angle. The vertex angle's right here and right here. And I just stated the vertex angles are congruent. That's just like over here. Vertex angles are congruent. Isosceles triangle, isosceles triangle. So we know this proof is definitely possible, and we know we're going to be able to prove it. We got to think how we're going to do it. Well, what I would state next is, I would state that angles 1 and 2 have to be congruent. Because remember, when two sides of a triangle are congruent, their opposite angles are congruent. I would also state somewhere that angles 5 and 6 are congruent, because whenever two sides of a triangle are congruent, their opposite angles are congruent. Now, after you state that in your proof, you should be able to make the connection that, because all of these add up to 180, that these two angles here are going to match these two angles over here. One of the reasons we're going to do a paragraph proof is going to be really, really easy compared to a 2-column proof, okay? So here's how you do a paragraph proof, and really, there's a lot more writing involved, but they're a lot easier to get right, okay, on a test or a quiz. So here we go. I would start off by putting your given. I would say GL is congruent to HL, and LJ is congruent to LK, because it's given. Okay? Then I would write this. Angles 3 and 4 are vertical. Thus, congruent. That's easy, okay? That's pretty simple. Now, guys, you don't have to give as much details in the paragraph proof as long on a test or a quiz. If I can follow your reasoning, then I'm totally good. So I would say something like this. Angles 1, 2, and 3 add up. That's up. Add up to 108 degrees. As do angles 4, 5, and 6. Okay? Then next I would state angle 1 is congruent to angle 2, because they're opposite congruent sides. Now I would put as are angles 5 and 6. And again, students, on a test or a quiz, I would give you, this is perfect. I would give you full credit for this, that you're explaining yourself very well, okay? You're just telling me angles 3 and 4 are vertical, thus congruent. You would say angles 1, 2, and 3 add up to 180, as do 4, 5, and 6. Angles 1 and 2 are opposite. They're congruent because they're opposite congruent sides, as are angles 5 and 6. And then you could jump right to this and say, thus, angles 1, 2, 5, and 6 are all what? Congruent. Because the angles have to add up to, or because the triangles have to add up to triangle GHL is similar to triangle KJL by the angle postulate. And that's it. Now I hope this has made sense. We did do, months and months ago, we looked at paragraph proofs, okay? And so I thought I would throw another one at you. To do this 2-column, you would have had to do something like this. Angle 1 plus 2 plus 3, I'm going to be really sloppy, equals 180. Angles 4 plus 5 plus 6 equals 180. And then you would have to substitute angle 3 for 4. So where this 3 is here, you could put a 4 and then bring over these two angles here. So angle 4 equals 180 minus 1 and 2. And then angle 4 equals 180 minus 5 and 6. Minus 5 minus 6. Minus 1 minus 2. And then you can set them equal to each other because angle 4 equals angle 4. And guys, that'd be really long, okay? You would have 180 minus 1 minus 2 equals 180 minus 5 minus 6. And then because we know 5 is congruent to 6, you gotta substitute 5 in for 6. And then substitute 1 in for 2. And just keep going and going. So in this case, a paragraph proof totally makes sense. I can follow all the reasoning in here. And you've proven to me that these two triangles are similar. Okay? Alright guys, that's it for today. I hope this video has made sense. You're responsible for the main thing we've covered today is this postulate right here. Now we're going to learn 2 other ways later in lesson 8.5. It's going to be the side theorem and the side angle side theorem, okay? And we'll get into those later, okay? Have a good day. Hope this video's been a help to you. If you have any questions, don't hesitate to call or email.